Hello and welcome to When Kubernetes Goes Bad and How Policy Enforcement Helps, presented by Fairwinds, a provider of managed services with a lot of expertise in Kubernetes. I'm your host today, Mike Vizard, and our speakers today are Joe Pelletier, who's Vice President of Product for Fairwinds, and Robert Brennan, who's Director of Open Source for Fairwinds. There will be 2 polls today that we're going to ask you guys to participate in. There will also be giving away 4 Amazon gift cards at the end of the presentation. And we encourage you all to find the questions tab in front of your screen there. And as we go along, feel free to use that to ask questions, and our speakers will happily share their expertise. With that, gentlemen, I'm going to hand it over to you.
Hey folks, I'm Robert Brennan. I'm a Director of Open Source Software here at Fairwinds. I drive all of our software initiatives here, and I've been working in the Kubernetes space for about 2 years now. Joe?
Yep, and my name is Joe Pelletier. I kind of head up the product and offerings here at Fairwinds, and I've been in the Kube space for a few years as well, and excited to speak with all of you today.
All right, well, we have our first poll here then, which is the question being, where are you on your Kubernetes journey? And we want you to select one answer, please. Your choices are learning about containers in Kubernetes, have spun up a test cluster, have started using it in pre-production, are using it in production, and I am a Kubernetes expert. We're going to give everybody a minute or so to answer this poll. All right, and we've got some answers here. Where are you in your Kubernetes journey? Learning about Kubernetes and containers is roughly 60%, followed by using it in production. And then everybody else is around somewhere around spinning up a test cluster, pre-production, or we have a small handful of Kubernetes experts. Gentlemen, take it away.
All right, thanks, Mike. So just to give you all a little background on Fairwinds, we are a Kubernetes enablement company, and that comprises a few different things. One is services, so we have a bunch of expert SREs who will help folks either spin up their first Kubernetes clusters, or will help manage those clusters going forward, making sure that everything stays up to date. Kubernetes itself stays up to date, all the add-ons on top stay up to date, carry pager for those clients, things like that, make sure those clusters are healthy and reliable and secure. On top of that, we have a lot of open source software, projects you may have heard of, such as Polaris and Goldilocks. These are open source projects that are really targeted at solving particular problems that we've hit as we manage all those Kubernetes clusters. And then finally, we have commercial software, namely Fairwinds Insights, which helps do a lot of policy-driven configuration management and validation to help folks really manage their Kubernetes configuration from the CI/CD, pull request process through admission control, and then all the way through scanning clusters as they're running. So we get a lot of questions from folks basically saying, I've got Kubernetes running, my app's working, what could go wrong? Why do I need help at this point? What do I need to be worried about? And the answer is really a lot. There are several different ways that we've seen clusters go wrong. We try to bucket it into a few different categories here. One big one is security. Security should be top of mind for anybody running a Kubernetes cluster. There are problems that can crop up from the cluster being misconfigured, from individual workloads being misconfigured in a way that would say allow privilege escalation, container vulnerabilities and ending up in the cluster. There are a lot of different ways to get security wrong as you're running a Kubernetes cluster. Another category is efficiency. We see a lot of clusters where workloads are not really running as efficiently as they could be, potentially because they haven't set CPU and memory requests and limits, potentially because they've set those requests and limits incorrectly. Often we see development teams will over-provision memory and CPU for their workloads in order to just get things running. So efficiency should be, again, top of mind for anybody running a Kubernetes cluster. The third category is reliability. So making sure that your workloads are staying up and healthy, making sure the cluster itself is staying up and healthy. There are a lot of different ways to kind of screw this up and end up with either with downtime for a particular workload or downtime for a cluster as a whole, which can be a real nightmare. And the last bit is consistency. Consistency becomes really important in a multi-tenant or multi-cluster environment. If you've got a lot of different teams that are deploying into Kubernetes or a lot of different clusters that have been spun up, making sure that those clusters are consistent, making sure all the configuration going into those clusters stays consistent is really important. And that might be from a security and compliance perspective, or just from like an internal auditing perspective, making sure that workloads are being labeled in a consistent way so that you can understand who's spending what. So how do misconfigurations happen? There's a few different ways that they can get into your cluster. One of the big ones, though, is just people copy and pasting stuff that they find either on the internet or within your own code base, things that might have been an early prototype just to get things in there, get things working. Copy pasting is probably the easiest way that these types of misconfigurations can propagate throughout an organization and end up becoming a big headache down the line. Another big category of how these problems end up occurring in the cluster is teams might have a mandate to get something done by a certain date. And so if it's not working, often the easiest way to get it working is to over-provision, either in terms of resources like memory and CPU, or in terms of security, getting things running as root or with cluster admin permissions. Often that's the easiest way to get things, to the point where it can be user-facing and working, but there are obvious security, reliability, and efficiency issues that come about because of that. And then the last reason we see misconfigurations crop up in clusters is because there's no process for verifying those configurations. Either there's not enough work being done at pull request time to do code review, or developers are reviewing their own code without any oversight from the ops team. And there's no policy in place, or no ability to audit what's already gotten into the cluster. So it's really important to have visibility into what's going into your cluster, both from a manual perspective through code review, and from sort of a more automated perspective using policy. So one big example of a problem that can enter your container or into your cluster is a vulnerable container. For every container out there, it has inside of it both the base operating system and a bunch of software installed on top of it. And new vulnerabilities are being announced regularly for all these libraries. It's important to make sure that you're scanning every container that goes into your cluster to make sure that you're not introducing any vulnerabilities into those clusters through these images. What's really important, though, is that you're not only scanning things as they go into the cluster, but you're proactively continuing to scan them. Because even if it passed the scan, the first time as it entered the cluster, it's possible that a CVE would be announced the next day, and suddenly you are running a vulnerability. And that's, not just a, something in the background. That's a publicly known vulnerability. So it's important to make sure that you're scanning containers on a regular basis and patching these vulnerabilities. Based on the data that we have at Fairwinds, roughly about 8% of containers that are running inside of a cluster contain known vulnerabilities and could potentially be exploited. That could be, exploiting the application that's running inside this container, or if they manage to exploit the application, using these vulnerabilities to escalate their permissions within the cluster. So another category of issues that we see is over-permissioned containers and deployments. This really occurs, one level up the stack when developers or ops teams are writing configuration to actually get those containers running inside the cluster. And there are a lot of hooks that Kubernetes provides to allow those containers to do things that aren't necessarily normal, or not things that your typical workload would need. They have to do with allowing that container to run as root. Allowing it access to the host node in certain ways through the network. Through the file system, things like that. A lot of security is not on by default in Kubernetes, and so it's kind of up to the user to set a tight security profile. And again, it's often easy to, if you need to get things working quickly, if you're say migrating an application to Kubernetes, sometimes the easiest way to migrate it is to, allow it to write to the file system, allow it to, have all sorts of capabilities that it might not actually need necessarily. Usually these capabilities are for things like, more infrastructure related things like Istio or, some networking security applications. Your typical API or web server is not going to need to do a lot of these more secure things. So making sure that your Kubernetes configuration that wraps those containers is tightened up is really important. We actually see a lot more prevalence of these configuration issues. Again, largely because Kubernetes doesn't set very strong defaults here. About 63% of deployments allow their workloads to run as a root user, and about 73% have modifiable file systems, which is typically not recommended. But again, these are settings that are on by default, so we see them crop up a lot. Tightening down these things can really make sure that attackers are kept, unable to escalate their permissions if they do manage to exploit your application. So moving on from security, another category of issues that we see are related to health probes. Liveness node probes and readiness probes are really how Kubernetes can tell whether your application is healthy or not. This helps Kubernetes scale your application, rotate pods out if those pods have crashed for some reason, things like that. It's really, this is a big part of how Kubernetes does its job. So making sure that you're setting liveness and readiness probes is really important to make sure that your workloads scale up and down appropriately, making sure that if you cut a new release, you don't experience any downtime during that release. And again, this is an optional part of Kubernetes configuration. Kubernetes itself is not going to complain if you don't set these. So you really have to proactively make sure that you and your team are setting liveness and readiness probes. We see a little bit more adoption of these features, but again, about 30% of workloads lack liveness or readiness probes. And this can be a huge issue for scaling up and making sure that your workloads are up and healthy and stable. And then another class of configuration issues we see is all around memory and CPU. We see, again, this is a field that is not required in your Kubernetes configuration. You can leave it out and Kubernetes will happily run your deployment. But if you introduce a memory leak, Kubernetes will just keep feeding more memory into your container until it runs out of memory on the node. It's really important to make sure you're setting memory and CPU, both requests and limits. Requests being, how much Kubernetes will make sure your application has access to, and limits being the maximum amount it will get before Kubernetes kicks out that node or throttles its CPU usage. Another class of issues we see around resource requests and limits is that development teams will set them potentially after being nagged by an ops team, but they'll set them way too high. It's hard to really tell in development mode how much CPU and memory your application really does need in production. So the easiest thing to do is to just ask for too much. Ask for 5 gigabytes of memory, even though your application will never use more than half a gig. Or ask for 2 CPUs, even though you've got nothing multi-threaded and you really only need 1 CPU. So it's really important to make sure that you're monitoring what these values are set to and how well they conform to the actual usage of the application, because otherwise you're going to quickly run out of resources in your container, in your cluster. You're going to have to spin up more nodes. You're going to have huge cost overruns. You may end up spending way more than you actually need to. Again, we see a lot of workloads that are failing to set these. About 25% don't set CPU and memory limits at all, which can be a huge issue. Again, if you have a memory leak or the application starts doing something unexpected, Kubernetes isn't going to know to kick that pod out. And then of the folks that do specify CPU and memory limits, 15% of those have over-provisioned their resources, we find. So by looking at their actual usage over time versus what those memory limits and requests, CPU limits and requests have been set to, we can see that about 15% have over-provisioned. And then our last example of misconfiguration is a lack of consistency. This becomes really important when you have many teams deploying into Kubernetes or many different clusters in your organization. Making sure that, for instance, folks are using the same labels to mark their application, say, in the example here on the right, we've used the app label in one instance and the application label in another instance. It seems like a small thing, but it can make it really hard to audit the cluster and see, say who is spending how much, which workloads belong to which teams. You can also see here we have a cost center code where one team hasn't set their cost center code. Making sure that you have a consistent application of those cost center codes across clusters is really important if that's a scheme that you're using. And then there are other things like you may decide you don't want to host images from a particular registry because it's proved unreliable or it could contain untrusted containers. You want to only use an internal registry, making sure that you're consistently pulling from that one registry rather than from any registry that developers might specify could be really important. This is a much broader category of checks. This really has a lot more to do with your organization's context, your organization's needs, your standards and schemas and things like that. But it's important to make sure you're doing things consistently across clusters and across workloads and namespaces within a given cluster. So these misconfigurations can have a huge business impact. There can be increased security risk. You can have problems around auditing and just understanding what's in your clusters if there's inconsistency. You can introduce potential for downtime, outages, things like that. You could end up spending way more on your cloud bill than you expected. You can see on the right here, we've seen 60% of IT security professionals have experienced some kind of security incident related to containers over the past year. And about half of containers use less than 30% of the CPU that they request, according to Datadog. So with that, we've got another poll here.
So our poll here is, how is Kubernetes used in your environment today? Your options are full service, every app team creates, manages Kubernetes. Next answer is DevOps manages clusters, developers manage container images. Answer number 3 is DevOps manages everything, including Kubernetes. And finally, we aren't running Kubernetes yet, so we can't really answer this question. So let's take a minute to see what our responses are. All right, our responses are, for the most part, people are DevOps manages clusters and developers manages container images. And we aren't running Kubernetes yet, are our 2 leading answers. And then followed, I guess, by a quarter of folks, DevOps manages everything Kubernetes, developers, and even the application code. And very few people are doing full service. Gentlemen, back to you.
Super interesting. This is Joe speaking from Fairwinds, and when you look at those results, it's clear that I think a lot of folks are still evaluating and looking into Kubernetes for the first time, which is great. I mean, this is going to be a presentation that will help you think about some of the considerations as you move forward on your container and kube journey. But it also feels like a kind of somewhat of an even split between DevOps managing everything and DevOps managing some of the clusters and sharing some of that responsibility with developers as well. And I think that really resonates with what we're seeing from customers in the market, where a lot of folks are trying to find that balance between how much does DevOps own and control around Kube versus how much do I enable my development teams to have more service ownership and control over their configurations. And I think in any of those models, as you move towards adopting Kube or thinking about adopting Kube, it's important to think about how you can put that governance and guardrails around Kubernetes to enable teams to deploy quickly, rapidly, and enable that high velocity organization. And I think that's really where policy enforcement can help a lot. So if you move to the next slide here, we'll dive into a little bit more around what is policy enforcement. And Robert, really helped us understand a number of examples of where Kubernetes can go wrong, right? A lot of them are configuration driven. a lot of them can affect security, efficiency, or reliability. And we're seeing that, as organizations adopt Kube, there is a number of folks out there who still kind of struggle with these challenges. We also know that everyone is interested in best practices around Kube. But one way to actually tackle the best practice problem is with something like policy enforcement. Policy really helps prevent common misconfigurations from being deployed into clusters. And when you can prevent these misconfigurations, you can enable that ultimately that development velocity, because teams begin standardizing on a way of deploying and a way of running their apps in Kube. Another kind of benefit of policy enforcement is the ability to enable IT compliance and governance, which for many companies who have to adhere to internal and external compliance standards, that becomes important to show that you have controls in place that allow you to meet those guidelines. And kind of the other category is really just around putting those guardrails in place so that teams kind of avoid making certain types of naive assumptions with Kube. One of the things that we'll move on and discuss here is a little bit around policies as code. And as the world moves towards cloud native infrastructure and cloud native technologies, everything is being kind of standardized in a code-like fashion. And the same is true with policy. An emerging kind of category called policy as code is coming to light, and it really allows organizations to kind of separate the policy definition and the policy enforcement. A lot of the policy definition is now being encoded in kind of domain-specific languages like Rego. Rego is a popular policy language that is used by the Open Policy Agent project. The Open Policy Agent, also known as OPA for short, is becoming a popular standard in the Kubernetes community for being able to apply these policies. And we'll talk a little bit about that later in this presentation as well. But I think, when we think about the policy as code movement, the benefits are really around version control, auditability, your ability to test policies, and making sure that they're repeatable, which is important for that consistency factor, especially as Kubernetes deployments, or Kubernetes adoption grows in the enterprise. So let's go take a look at the next slide here and get a better understanding of how policies are being used today. Really, from what we can tell, organizations are leveraging policy in kind of two different ways. One is, I'm going to call it the audit mode way, and that's really the ability to monitor existing resources and workloads in a cluster so that you can identify what's misconfigured now or what the current estate looks like from a configuration perspective, so that you can either generate compliance reports or help prioritize improvements or any sort of security fixes as a result. So, it's very common for companies to do a POC of Kubernetes, get their test cluster stood up, and then over time, start deploying production workloads to that cluster. But they may have neglected to think about policy, or they may have neglected to think about what are the best practices that we want to govern for our org. Audit mode for policy enforcement really allows you to just understand the current state of what's going on in that cluster, so you can then just make those next step decisions. The second kind of way policies are being used is enforcement mode. And I think that's how most companies or how most engineers think about policy. I think they generally think about it from an enforcement standpoint, which is really, that notion of you're going to have a team, they're going to be deploying into that Kubernetes cluster. How do I prevent that user or that process from deploying things that violate my conventions or my norms for my organization? And this is really a great way to kind of mature your policy usage, where you create those guardrails for what a good deployment looks like or what a bad deployment looks like. And ultimately, with the right balance of enforcement rules, you can reduce the risk associated with activities like upgrades and being able to make fixes to configuration so that you can maintain the cluster over a long period of time. So let's move on to the next slide, where we kind of discuss different types of policies. We've thought about policies a few different ways. As we've been working with our customers on policy enforcement, we've kind of grouped the categories of policies that apply into 3 different buckets. The first one we'll call kind of standard or universal policies. And these are really kind of basic policies that enable general best practices in any Kubernetes cluster that you might be running. We'll share a couple real-world examples on the next slide in just a minute, but generally these policies are going to cover a wide variety of areas like security, efficiency, and reliability. There are also environment-specific policies that might be applied to specific namespaces or specific clusters like a dev cluster or a QA cluster. And in an environment-specific policy, for example, you might have your QA cluster more relaxed. It may not have as strict of a policy because you want to enable developers to get their app out there and test it and make sure it works, and you don't want to block that activity. But in production, you might want to ratchet up the strictness of your policy so that you can avoid those production mistakes. In other cases, there might be certain namespaces in your cluster that are really meant for platform resources. So you could think about namespaces in a cluster that are focused just on monitoring or certificate management or DNS, et cetera. And you don't want development teams to accidentally deploy something in there or change the configuration around that namespace. So you may put policies that kind of govern what can be done in that context. The final category is going to really be cluster-specific policies, and I would just say that for all intents and purposes, these might be one-offs on a cluster-by-cluster basis. Example might be edge computing, where if you have an edge cluster, those might follow a completely different set of policies and procedures than a traditional cluster serving up traditional workloads. But let's talk about what those sensible defaults for policy enforcement are. This is really where I think most companies are going to get the biggest ROI on day one. And frankly, there's actually a few dozen, different sensible defaults that are out there in the community to take a look at. Here, we're boiling it down to just a few that we've seen really valuable by some of our customers. And we've worked with some of our customers to implement these policies today. So let's take a look at the first one, which is preventing deployments to the default namespace. This is, can be a general just best practice. You want to generally have your workloads in a namespace so that you understand ownership and you can embrace certain aspects of that service ownership so that things are more logically organized in the cluster. Another one is requiring labels on resources. Robert shared an example earlier where you might have labels around who the app team that owns this service is or what cost center that service belongs to. That's really important, again, for just making sure that the cluster is well organized, because when there are certain activities like upgrades or security patching that's required to the cluster, you want to make sure that you have a sense of the application landscape that's running in there and that things can continue to run after those upgrades. So being able to take inventory of who's deployed what with the use of labels can be really, really powerful. I won't go through the whole list, but the last one I'll touch upon is really that resource requests needing to be set. Robert talked about how that's a general best practice, but there's about 30% of organizations don't even set these today. And part of the reason why that's a tricky problem to solve is because you kind of have to get visibility into how that workload's actually consuming the resources available in the cluster already. And so at Fairwinds, we've developed some software to help with that. One is an open source tool called Goldilocks, which can help make this problem easier to solve and allow you to apply a policy so that you are aligned with more of those best practices. The final thing I'll point out here, though, is that there is a prolific number of examples out there in the community. Fairwinds is maintaining a library of policy examples written in Rego as part of the Open Policy Agent project. And the Open Policy Agent project as well has their own dedicated library on GitHub. And so we provided the links to both for you all to take a look and poke through at the different examples out there. So as we move on, when does it make sense to actually apply policy enforcement, right? And it was, again, looking back at that poll question, it's really interesting to see the results from the webinar. And I think it really speaks to how organizations, the role of DevOps is going to vary depending on the culture and how much service ownership is going to be given to the end development team versus not. And I think in any scenario, policy is going to help both that platform engineering team and the ultimate development teams to go faster with in different ways. So in general, I think policy enforcement though becomes increasingly more and more valuable as companies make a bigger and bigger investment in Kube. Generally, when you're going from one team to many teams who are using Kubernetes, policy becomes sort of an overnight important decision for you to make. And we see this a lot happening when organizations leverage a shared cluster. So imagine you're a platform engineering or operations team. You're building and managing a Kubernetes cluster today that actually serves multiple app teams. So you essentially have multiple end customers. It's really important to ensure that those customers are not accidentally interfering with their own work streams, and policy can be a way to help put those guardrails in place. Another example of when policy enforcement makes sense is sort of that multi-cluster environment. And this is true when, similar situation, you have multiple clusters that are serving multiple teams, potentially a blend between the cloud and on-prem. And you want to make sure that, applications are being directed to the right environments and that you have policies that can be repeated across different environments. So the beauty of policy enforcement and policy as code is that you can reuse a lot of those policies as you build and expand Kubernetes. It gives you that repeatability because everything is kind of version controlled and stored in Git, and it can enable you to really apply policy across all the clusters that might be growing in your company. So let's think about, in this next step, sort of what makes the most sense in terms of logical rollout of policies, right? Like if you're convinced at this point that policies are important for you to look at, what makes the most sense to start with today? And I think step one is really going back to that use case of audit mode, leveraging a set of policies to understand within your cluster today what is currently already violating those policies. So before you even enforce or block deployments into the cluster, it's important to just prioritize the current issues that may exist today so that you can understand what should we address immediately versus what should we be planning as improvements later down the road. A second step is once you feel comfortable with the audit mode step is then integrating sort of a feedback loop into the CI/CD process. And that gives sort of your DevOps team or your developers, depending on whoever's responsible for the configuration, early feedback on whether or not that configuration, which is generally manifests itself as YAML code, has any violations of policy. And then the third one is an admission controller enforcement, which we'll speak to in just a second. And that's really that last gate where policy enforcement is likely the most strict because it applies guardrails around what can go into the cluster and what cannot. So if we move to the next slide, we'll have sort of a visual representation of sort of what we're talking about here. And this is just sort of a typical implementation. It could vary depending on your organization. But you'll see that starting at the left, everything sort of originates with policies as code in a repo. And like we mentioned earlier, the OPA project has embraced a DSL language called Rego to write their policies. But when you then think about what's running in the cluster, you have a policy engine of sorts and an admission controller. And what the admission controller is going to do is it's really going to block the deployments going to the cluster that don't meet the policies as defined in the policy as code repo. At the same time, that policy engine in step one in the diagram can produce a report usually every 15 minutes or every hour, whatever frequency makes sense for you, that tells you where you sit today from a compliance standpoint. How many workloads are conforming to your policies versus how many workloads are not conforming to your policies. And then finally, on that step 2 area, you'll see that the CI plugin is another area where policies can be interpreted and feedback can be given to the developer well before they're actually deploying into the cluster. It's another early warning indicator that there might be something wrong with how that YAML code has been configured. So if this sounds interesting, I think we want to share with you on the next slide 2 different options around how to get started. The first, there's several open source options that are emerging in the community around policy. Fairwinds has been in this space for quite some time. We actually have an open source project called Polaris that provides out-of-the-box 20 built-in checks. And they cover a variety of use cases too. It covers security checks, efficiency checks, as well as reliability checks around your Kubernetes configuration. We've gotten a lot of great feedback around Polaris where companies leverage this as generally a starting point with that audit mode use case where they run it in the cluster to understand what do I need to prioritize as improvements now versus later. And over time, folks might be able to leverage Polaris, get their cluster in good shape, and then want to go to an advanced next step. And that advanced use case is really where Open Policy Agent shines. The OPA project gives you a lot of flexibility around defining your policies using that Rego language we talked about, and being able to have very fine-grained rules around that. And so, I think these are 2 great options for you to be pursuing. And what we've decided at Fairwinds on the next slide is we've actually built a product that integrates both Polaris, OPA, and several other open source auditing and policy tools into one platform. Because we're seeing a lot of organizations take this sort of methodical maturity step where they start with something like Polaris, they move into OPA to do more advanced policies, and then they also want to expand and run more security type of checks in their cluster to gain more visibility into the types of issues that might exist. With our Fairwinds Insights offering, we also integrate with different DevOps tools like CI/CD platforms, ticketing systems, Slack, etc. And it really runs wherever Kube may exist. So if we move forward, really it becomes sort of a comprehensive platform that helps you fit between development and ops. And if we think about the poll question from earlier, very few companies have developers in full control of operations. I think a lot of companies aren't there yet. And the tooling and the complexity in this space, isn't there to really give developers the leverage they need. And that's why DevOps exists, is how do we enable that collaboration between development and operations folks. And so if you're an organization where you do have a DevOps function, but there's a depending on the team or depending on the culture, there's a certain amount of shared responsibility between dev and ops, Fairwinds Insights can be a really good choice for getting policy enforcement integrated at the earliest stage, which is CI/CD, and rolled out all the way through to production with a suite of really best of breed policy and auditing tools for Kube. And with that, I think we can share with you just a couple of the use cases we've heard from customers recently, how they've recently used Fairwinds Insights. They use it for that cluster audit where they audit their clusters for security, reliability, and efficiency issues. They then go to that next step and they create, define, and enforce policy. And more recently, we're seeing our customers leverage Fairwinds Insights to provide, optimizations to their workloads so that they can have the right balance of CPU and memory and ensure that their clusters are running efficiently as they scale and grow their usage. So with that, I think we want to just make sure the folks on this call know about our free trial. We also have a free community tier if you're interested in using it for a longer than 30 days. And so we're interested in your feedback and hearing any questions that you might have. And so I think I'll turn it back over to Mike for any of the Q&A that has come up.
All right, great. Let's jump into that. Folks, we want to encourage you to find that question button and plug in whatever's on your mind, but let's go to our first question. If you're building a cluster for the first time, when should you start thinking about policy, gentlemen?
Yes, I can answer that. I think a lot of folks, as they're building out a first cluster, they haven't hit a lot of the problems that come with the more mature Kubernetes cluster. So they don't really think about policy out of the gates. I think it's really important to start setting up a few basic guardrails as you're rolling out your first cluster. They can be policies as simple as like don't deploy into the default namespace, make sure liveness and readiness probes are set on everything. But just at least starting to establish some good habits around policy. So that you have those instincts in place, so that as you do mature, you get more teams deploying into Kube, and you start to hit real problems. It's really easy for you to say deploy new policies in order to set up some guardrails based on your experiences there.
All right, great. Our next question is, how do you know when the right resources request limits have been set? It seems like there's a lot of options out there. So what is the right balance?
Yeah, that's a great question. I'll start it off, and I think Robert might have some feedback on this as well. With resource requests and limits, I mean, technically you can run your workloads in Kubernetes without them, but Kubernetes will apply a default, and it's a pretty risky thing to do because Kube may, consume all the CPU and memory on that node if you don't provide sort of the minimum or the limit value that's required for that workload. And what we've noticed is a lot of folks today will kind of rely on looking at their monitoring tools and kind of going back in time to understand what are those lower and upper limits that they've seen that workload run. But one of the recent kind of innovations in the community has been around the vertical pod autoscaler recommendation mode, and we take advantage of that open source with our Goldilocks offering to just provide straightforward recommendations on what we think the CPU and memory should be for that workload. And that generally helps make the problem easier to solve. But I don't know, Robert, if you have any other thoughts on that issue.
No, yeah, I'd just say, Goldilocks and Insights as well are able to, really look at your actual usage and compare that to your requests and limits. I think it's something that, teams need to tune on an ongoing basis, as their application grows, their user base grows. The appropriate limits and requests might change over time. So it's something to just constantly be keeping an eye on and tuning.
All right. Our next question goes to Polaris. Does Polaris do security checks on running containers?
So Polaris won't check a running container. What Polaris checks really is the Kubernetes manifests that wrap those containers and tell Kubernetes how to handle those containers. So it's more like a static analysis of the Kubernetes configuration. If you're looking for more runtime security, Sysdig has a project called Falco, which does a lot of runtime security. It's a little more heavyweight, to have basically an extra application running inside of or alongside each of your containers to monitor them. So it's a little bit scarier, a little bit harder to set up, but it's out there for sure.
All right, our next question, I'm not sure I'm going to get this right, but I'm going to read it. But in terms of implementation, where does it come in terms of Kubernetes node structure? Does it require custom Kubernetes controller, kubeadmin? I guess, what are the tools for you for spinning up a Kubernetes cluster?
So I think this question is in terms of policy enforcement. Feel free to chime back in if I interpreted that wrong. But for policy enforcement, specifically the admission controller is probably what you're asking about here. That runs as what's called a validating webhook inside the cluster. Basically, the validating webhook sits alongside the Kubernetes API. There are some validating webhooks out there. Fairwinds Insights provides one. OPA Gatekeeper is another validating webhook that exists. You install these in your cluster. You can create your own from scratch using Golang as well. And they sit alongside the Kubernetes API. And basically, any API request that comes in, anybody that runs a kubectl command or even anything inside the cluster, like an operator running in the cluster, anytime they try to do something that matches the rule set for your validating webhook, the webhook will trigger, and it basically gets to respond, okay, you're allowed to do this or you're not allowed to do this. It doesn't require anything, messing with the nodes or kubeadm or anything like that. It's really just another application running inside of Kubernetes that plugs into this first-class Kubernetes concept of a validating webhook. Hopefully that answered your question. Feel free to ask again if you want to get more specific.
Well, the person asking the question just said right and absolutely, so we're spot on. Okay.
Sweet.
I guess the next question I would ask you guys, we hear the stories about misconfigurations of Kubernetes all the time, but are there more misconfigurations in Kubernetes environments than other environments? Because this issue has been around for a long time. And if so, why?
Yeah, that's a really good question. I would say Kubernetes has really tried to pull a lot of cloud functionality that's been spread out in a lot of different places. It's tried to pull it under the same roof. And so, that on the one hand makes things a lot easier to reason about. We have fewer things we need to check. There are fewer kind of unknown unknowns in your environment if everything's running inside of Kubernetes. But it also means that the surface inside of Kubernetes is much larger than, say, in any particular place that might have existed before Kubernetes. So I would say it's a much easier problem to get your arms around with Kubernetes, but it's still a very, very big problem.
Yeah, I would definitely echo what Robert said. I also think some of the things that we're hearing in, we've run some stats here, right? We shared some information that we have around the prevalence of some of these issues. And we're hearing like a lot of folks, they're still trying to learn Kube, right? And so they might copy and paste a lot of examples and sample configurations and apply it and maybe never revisit it. And when it comes down to upgrading and maintaining the cluster over the long term, I think that's where some of these misconfigurations can become problematic in terms of accruing technical debt and ultimately slowing down teams when you lack that consistency. And so we think that that's part of the problem here that policies can also help solve.
Do you guys see a lot of curated instances of Kubernetes, or are people rolling their own? And is it more dangerous for configurations to roll your own, or is it an issue everywhere?
So I will say, if you're using GKE, EKS, these managed Kubernetes services, that takes a lot of the really low level cluster level stuff out of your hands, which is nice. That stuff can get really hairy really fast if you're, say, running your own Kubernetes cluster on-prem or on EC2 instances. There's a lot of extra stuff that you need to take into account on how those master nodes are configured and how Kubernetes itself is configured. So rolling your own definitely comes with a bunch of extra things to worry about. And there are some cool projects like Sonobui, I believe is the name of the project, which will audit that cluster level configuration to make sure you're not doing anything wrong there. But more and more we're seeing folks, starting with GKE, EKS, AKS, these more managed Kubernetes services, where they get to kind of forget about that cluster level configuration and really just worry about their workload configuration and the add-ons that they're sticking into the cluster on top of that baseline.
We talked a bit about over-provisioning. Is this a bigger concern now, given the current economic climate? Are people really focused on that, or are they still just throwing resources at their issues because it's the safer way to go no matter what the cost is?
Yeah, that's a great question. I think we're seeing definitely a lot more interest in making sure that workloads are running efficiently. I think the cloud cost, the cost problem in general, it can be solved. It's a multi-layered problem, right? I mean, there's a number of different ways to address cost when it comes to the cloud. I think when it's specifically when you're running Kubernetes, one of the ways you can address cost is by making sure that you're using the right amount of CPU memory for applications and not over committing those applications. And so I think specific to just the Kube space, this is one of the levers that you can use to reduce cost. I think that is an area that will continue to be of interest, especially as companies scale their Kubernetes usage and they realize that this has gone from a problem that was manageable with a few app teams or a few users to one now that they have to build more processes around.
Well, let me just follow up on that. Do you see a lot more of these larger clusters, or are people deploying a lot of smaller clusters, or is it a mix of both, or are we starting to see monster clusters?
It's a great question. Personally, I've seen a mix of both, and I think it kind of goes back to those different scenarios we talked about around shared clusters and multi-clusters. And so to give you an example, we're definitely seeing a trend around folks building shared cluster environments where multiple teams deploy to that shared cluster. That's a trend where I would say more, companies where they're making sort of methodical move out to Kube, adding teams one by one. That's sort of the pattern that we're seeing there. There's other organizations where they might be embracing Kubernetes across all the business units, and there might be less governance in place. And in that scenario, we're seeing lots of clusters. And I think that becomes a complicated space as well, where policy is important, but you also have to figure out who owns which cluster and what are some of the conventions that you want to put in place there. So I think a lot of sort of the organizational strategy around Kubernetes kind of dictates how the clusters get the size and the number, and it will likely vary from company to company on where they are on the maturity curve.
All right, we also have a question on EKS because I guess AWS reInvent is top of mind for the month. The question is, to what degree does Fairwinds Insight enhance EKS, or for that matter, what's your relationship with AWS and EKS?
Yeah, good question. I'll let you take it, Robert. Yep.
Sure, yeah. So Insights absolutely works with EKS and with any of the other managed Kubernetes providers. It works very well with them, actually. With managed Kubernetes like EKS, AKS, GKE, what they're really providing for you is the control plane of Kubernetes. Everything else in terms of your workload configuration, your networking setup, how you're managing ingress, everything else is left up to you. And that's really where Fairwinds Insights comes into play. Fairwinds Insights is really about checking that workload configuration, checking resource usage, enforcing policy around workloads. So Fairwinds Insights really plays at that, at that worker node level, or at the, at the workload and configuration level. So it really doesn't do a lot at the level that EKS is taking care of for you. So I just say Insights works really well with any of the managed Kubernetes providers.
All right, great. You guys talked early on about roles and who's in charge of what. And we had the poll. What do you think is going to happen going forward? Is everything going to shift to this DevOps CLI API shift, or is there room for administrators to use some sort of GUI tool to manage Kubernetes clusters, and we'll have some sort of bifurcation of roles? How do you see this all playing out?
Yeah, I'd say the one of the anti-patterns that I have seen cropping up is that you have an ops team who is in charge of everything, basically. The app developers just write their application code, and the ops team is responsible for writing Docker files, writing the configuration around those Docker files, getting everything shipped into the cluster. And that can work well if you've got one or two teams. But once you really start to scale up, and you have a variety of different teams using a variety of programming languages and things like that, that really just doesn't scale very well. So I think the best companies we've seen have a really nice handoff between dev and ops, where the developers take care of writing those Docker files, writing the basic deployment configuration, maybe with some guardrails in place from the ops team, whether that's a policy enforcement engine, or maybe they provide templates for how to write those configuration files. But it's the development teams that are responsible for the day-to-day updating of those bits, because there really is a lot of application-specific knowledge that goes into knowing how much CPU and memory your application should be using, knowing what environment variables need to be set, knowing how to check for liveness and readiness. I think app teams really should own those things. And then you asked about dashboarding too, which I think is going to be an increasingly interesting thing to watch in the Kubernetes space. Right now, I think almost everything happens through kubectl and through like automated processes like CI/CD. I would say more and more, at least from a visibility perspective, folks are going to be looking to dashboards to make sense of the complexity of Kubernetes. It is such a there's so much inside of a Kubernetes cluster. There's so much going on that it can be hard to even know which kubectl commands to run in order to get the information you need. So having some kind of dashboard, some kind of visualization in front of you to kind of show you what's going on and tell you what questions you should be asking, I think is increasingly important.
Yeah, I 100% agree with Robert's point of view there, and I think if we think about Kubernetes in terms of just sort of the adoption lifecycle, it's starting to enter the mainstream, right? A lot of mainstream companies are thinking about and experimenting with Kube. Even our survey today kind of suggested that as well. And I think as you enter the mainstream, having more dashboards and user interfaces on top of Kubernetes will make it easier to adopt. It will reduce the complexity. And allow folks to easily prioritize how to apply policies and what types of issues need their attention. So I think it's going to be an important part of the Kubernetes kind of journey that a lot of companies go on.
You guys mentioned that in your observation, 8% of containers have known vulnerabilities. Did you guys look at what kind of vulnerabilities they are? Because I hear a lot about cryptojacking, but not much else. But I don't know what you guys are seeing.
Yeah, it's really across the board. The container vulnerabilities can be kind of noisy because it can be something going on in a library that you're not using just because you used a very large base operating system for your application. It might be something in the Git client that was already installed in that operating system which you're not actually using. So it can be hard to kind of triage through those issues. But really, I think the important thing is I think the easiest way to handle those issues is to make sure there aren't any. It's much harder to, like, if you see I've got a container image that's vulnerable, trying to go through the process of asking yourself, well, am I using this vulnerability? Am I actually vulnerable to it? Is there a chance for somebody to break into my container using this vulnerability? You could spend days or weeks doing that investigation, and it's usually much faster to just make a quick fix, update the operating system, use a different operating system, update the library, whatever it is.
Yeah, I think a lot of companies will be taking a risk-based approach when it comes to container vulnerabilities. We're seeing companies look to detect container vulnerabilities in kind of a number of places. One is part of the CI process. They might be detecting container vulnerabilities as part of their image registry. And finally, in the cluster too, trying to understand for what's already deployed, what's the current vulnerability status of that container, and have any new vulnerabilities been introduced since I last deployed that container. I think organizations are getting the visibility. I think they're going to ultimately have to take a risk-based approach to prioritizing.
All right, great. Hey guys, we're out of time. I'm sure we have tons of questions. So if you want to keep sending stuff in to folks, we'll get somebody to answer those. I want to thank our panelists today for sharing their expertise. And I also want to call out the winners of the Amazon card raffle. They are James S., Jesse R., Warren W., Karen M. Congratulations to you all, and thank you for spending some time with us, and we hope to see you again real soon. Take care.
Thanks, Mike.
Thanks, Mike.